today we have 10, 11, 12. Okay, if you look at 10, 11, and 12, right? Now, these are actually very recent past year questions, 2020, 2018, 2017. So sequences and series, right, is the one of the chapter where you will see up to 2 questions per year. One question on the sigma notation, one question on recurrence relation. Yeah. So usually like that. Vectors also is another one. This chapter is another one. Last time complex, there's 2 questions also, but I think they reduced one chapter, so likely we'll only expect 1 question. Okay. So so now for 10, 11, 12, right, we are towards recurrence relation, that side. Okay, not so much of the sigma notation where things are chunky and ugly, which I deleted already, but where things are chunky and ugly, but yeah, now we are going to go to something like that. Okay, so obviously it's not going to be as easy as the previous question over here, question 8. Okay, this one very straightforward. Okay, but for question, okay, for this one over here, right, let's see. Even though it looks hard, but technically still can do one. Can So let's okay, let me start with question 10. Okay, question 10. We have a sequence of numbers. Why is this here? Okay. Okay, U1, U2, U3, okay, has a sum of Sn, where Sn equals to sum from 1 to n of UR. Okay, so they define like that, sum of n. Okay, is given that we get a general formula over here where A and B are non-zero constants. So because of that, find an expression for Un in terms of A, B, and n. Simplify your answer. So for this one, we have Sn. We're going to find Tn or Un. What can we do? What's the property that we can use? Okay, Sn minus 1. So your general term would be the sum of n minus sum of n minus 1. Okay, so Un would be equals to an square plus bn, okay, minus of a times n minus 1 square plus b times n minus 1, like that. Okay, so with this, we have something like an square plus bn minus, okay, an square minus 2an plus a plus bn minus b, something like that. Okay, expand out nicely. So we get something like, okay, so before we simplify, right, this will minus this, bn minus bn. So we have something like a, oh sorry, okay, we have 2an minus a plus b. Okay, so double check the instruction. This un is in terms of a, b, and n. Okay, simplify our answer like that. Okay, can Okay, so part 1 is just applying the concept law. Okay, like that, 3 marks already, very nice. Okay, now it is given that the 10th term is 48. So it means that this sentence tells us that U10 is equals to 48. Then U17, 17th term is 90. Okay, find A and B. So this one over here means that part 2. Okay, so U10 would be equals to 2A10, correct? Minus A plus B. This one is equals to 48. So rearrange, right? I have 19A plus B equals to 48. So this is equation 1. Okay, second one, 17 is 90. So U17, so this will be 2AN minus A plus B. This one equals to 90. So our 33A plus B is equals to 90. Okay, so this one is, okay, this one I see the marks, right? 2 marks. So generally speaking, you can use from GC. Okay, if you're lazy, you from GC lah, but otherwise it's a very easy elimination. So A equals to 3, B equals to -9. Okay, something like that. So it's making use of the previous one to put here. So even though, let's say, if this answer wrong, likely you can get 1 out of the 2 marks. Last mark, accuracy mark, lose. That's all. Okay. Questions? Any questions so far? Straightforward, oh? Okay. Now, then the next one is the headache. Okay, can the next one is the headache. Okay, can. You need time to copy? Still need to copy? No need, I move on. Okay, wait, someone's copying. Okay, let's move on. Okay, part B. Part B is the headache now, but the headache is not that bad. Okay, let's see. So we have this the Lambert ratio test. Okay, Lambert. I also don't know how to pronounce that. Yeah, Lambert ratio test. Okay, states that a series of they give this and that. Okay, using the test, explain why this series converges with X. States the sum of unity. Okay, so what is this? How come suddenly ask this kind of thing? I never learned before, right? So precisely, right? You never learned before. That's the problem with this question. Okay, so for this particular question, right, the thing is that sometimes they will throw in things that are outside of H2 syllabus. Okay, but if they want you to use concepts outside of H2 syllabus, right, they will provide you the theorem. Okay, they will provide you the theorem. They will provide you the results. Do you need me to go and ask them to keep quiet a bit? Or you're okay? Can you're fine? Fine now. Okay, can. Okay, so this one over here, right, is the results that they give or the theorem that they give. Okay, so let's analyze this and let's see how do we apply to this particular one. Okay, so let's see. We have the ratio test that says that a series of this form, series. Okay, can so this series over here converges when the ratio of the term, the limit of the ratio of the term is less than 1. Okay, and diverges when the ratio of the terms, the limit will be more than 1. When the limit is equals to 1, the test is inconclusive. So means that we have first case, second case, third case. Then we want to see whether is it converge, diverge, or inconclusive. Something like that. Okay, so right now, right, over here, right, if you want to compare, right, they say that we are looking at series. So what is my AR? If you compare the form, right, this over here, okay, this over here is AR. So A sub R will be X power R over R factorial. So this is the one. Yeah, go ahead, go ahead. Can So this is the one. Okay, so over here, I will let the general AR term to be X power R over R factorial first. Okay, so the idea is you look at the question, right? What is the comparison? How do you fit into this form? And now we're going to do AR, right? We need to test this AR AN plus 1 over AN. Okay, so let's try to find and see. So let's try to apply limits as n goes to infinity because they asked us to test, right? So this is a test of, okay, so AN plus 1 over AN. Okay, something like that. So this one will be equals to, okay, sub in. Okay, so now let's put in the n plus 1 term. So this will be x to the power of n plus 1 divided by n plus 1 factorial. Okay, whole thing divided by x to the power of n over n factorial. Okay, so this means that we are going to look at this fraction. Okay, so far so good. So far so good. So even though now that you see something that's very foreign, right? You just need to understand what's the question trying to ask. Okay, look for common structures. Okay, and then apply. If they ask you to apply the test, that means you are applying this lah. Okay, a of n plus 1 divided by n, something like that. Okay, there's also one more question on integration where they ask you to find the length of a curve, then they give you the formula, right? Then you just need to differentiate accordingly to get that formula out. Then you just apply that formula to use the curve. So things like that will happen in H2 math. Okay, why they do this? They want to see whether are you able to be adaptable also. Okay, not just critical thinking, but also to be adaptable in your thinking. Okay. Technically, like math is not a dead subject, math is a live subject, so it requires you to think a bit. Okay? Yeah, it is A level lah, so advanced lah. So okay, so what do we do now? How do we simplify? Okay, we keep, change, flip because this is fraction, right? So your primary school tell you keep, okay, from divide become times, then flip like that, right? Okay, next thing that we can do, okay, how do we simplify the x and x? This one over here, we can cancel lah, right? We can cancel the xn and we get something else. Then n factorial and n plus 1 factorial, right? We can also cancel out. So I want to remind you this example that I gave you the other time. This is 5 times 4 factorial. We can do something like that also. Okay, so how do I simplify? So this will be x power n times x divided by, okay, let me break this out, n plus 1 n factorial, first one. Okay, second fraction stays the same. Okay, I will break out like that. Okay, now let's cancel. I can cancel this. I can cancel my n factorial. So all the way, I will get something like limit as n goes to infinity of x over n plus 1 modulus. Okay. So the first part is the application part. Give you the thing you need to be brave to apply. Okay, next, the next one, right, is actually the important part that we need to think of. This one is a conceptual part. Okay, so what does this equal to? Okay, so this one, right, you see, you can technically bring the x out because over here, right, we are taking limit of n to infinity. So the one that goes to infinity is not x, but it is n plus 1. Okay, the 0 is correct. Okay, so technically speaking, we can bring the x out as n goes. So you can skip this step if you want. Okay, and then this one would be x times 0. Then this will be equals to 0. Okay, conclusion, because this is 0, right? So conclusion, the limit where n goes to infinity of a n plus 1 over a n is equal to 0, which is less than 1. So by the theorem that you see over there, by the test, this one will converge. So r from 0 to infinity of x power n over r factor x power r. Hmm? Inconclusive, man? No, equals to 1. Is given in the question. Question, read question. Mm. Yeah. It should go to 0 lah, as much as possible, because the ratio should be small. Ma. If the ratio is the same, right, that means it's a constant sequence. You get what I mean? So what's interesting? No, not necessarily. This is smaller. That's why it's smaller for this case. Yeah. That's why the ratio less than 1, ma. It's like GP lah. Your ratio, the common ratio must be less than 1. And that's why it will converge. Otherwise, it will diverge. Okay? Again, for this question, we define ourselves because what was the one that I say? Based on this question, they give the theorem, right? Use it. How to use? We match. Have to match, right? You see the two purple color that I highlight? No. X is all real value of X. But you're rolling the R different. Yep. Huh? No. R factor bigger. R factor bigger. Right? power. R factorial bigger because you got the extra terms behind. Yeah, factorial very fast one. Okay, let's look at part 2. More like the subsequent part. Okay, we explain why it converge already. Then state the sum to infinity of this series in terms of x. So what is the sum to infinity? This one, right, you have to do some, you have to recognize that. What is this? Okay, so what's the sum to infinity? If you cannot see, right, more, then you do term by term. So this r, you start with 0, right? So x power 0, 0 factorial, this is 1. When r is 1, x power 1 over 1 factorial. So plus x over 1. When it's r equals to 2, will be x squared over 2 factorial. Then x cubed over 3 factorial. X power 4 over 4 factorial, and so on and so forth. Is this very familiar? You've done Maclaurin of. Very good, right? Maclaurin of. Good. So this one will be equals to e power x. So it will converge to e power x. Okay? Can so something like that. Can. So the thing for this question is no choice but just to do it. Okay, so don't be afraid. Okay, don't be afraid. Try your best to get something out from here. If this one cannot do, then you try your best to figure things out. If really cannot, then no choice. Okay, can. So with this, right, I also want to point out to MF27. Okay, I quickly roll to MF27 to show you that actually this thing exists. If you go to the page with the series expansion. Okay, if you go to the page with this series expansion, right? So now, right, let's try to write this out in terms of, yeah. So now let's try to write this out in terms of the general term. Okay, try to write out the sum of the individual terms, right, as a summation. So this one is actually sum from 0 to infinity of x to the power of r over r factorial. You see this general term? Okay, so same thing, this one over here, right? Okay, sum from r equals to 1 or 0, 0 to infinity of this. Okay, so it's to make use of this. Okay, and then yeah. Okay, likewise. Okay, can so technically speaking, right, your general term over here, can see? So all these are sum from 0 to infinity of these terms. Can this one, the binomial one, a bit hard to write, but you notice, right, even the last chapter, I also write for you already. Sum from r equals to 0 to infinity of fn0 divided by r factorial x power r. Remember this? I also try to use the summation for you already. This one over here, r equals to 0 to infinity. This technically is this one would be n choose r of a to the power of n minus r, and then x to the power of r, something like that, right? Yeah, we learned this, but I'm just trying to show you that I've already used the sigma notation with you previously, right? Right, so it's like that long. So like for this kind of question, you just need to be familiar with what are you adding. Okay, what are you adding? What are you doing over here? Okay, can so the things they ask, right, won't be too far from here. If they want you to use something outside the syllabus, they will give you the theorem, and then they will also try to link back with whatever that you've learned. Okay, can so this one will be question 10. Okay, not so bad one. Looks bad, but not so bad. Okay, let's take a look at 11. Okay, any questions for question 10? Can or not? Can all right. 11. Okay, we have a sequence U1, U2, U3 is such that we get a recurrence relation over here. Okay, so this one over here is our recurrence relation. Okay, means that I will need the previous term to work on my answer. Okay, where A is constant and N more than 1. So part 1, given that the first term is 5, second term is 15, find A and U3. So we make use of this first, right? They give us the first two terms, so let's link the first two terms in this formula using this expression. Okay, so U of N plus 1 is equals to 2 times U of N plus A times N. So U2 would be equals to 2 times U1 plus A times 2. Okay? Sorry, A times N. Sorry, A times 1. Yeah, the N plus 1 is 2. Okay? Can and this one over here will be equals to 15. Right? So over here we have okay, 2 times 5 plus A is equals to 15. So A will be equals to 5. Okay, so this is how we find A. Can all right. And because of this, let's look for the third term, term number 3. So this would be 2 times U previous term plus A times N. N for this case is 2. A is 5, N is 2. Okay, so this will be 2 times 15 plus 5 times 2. So this one over here would be 40. Okay, which one? Don't need to make a because right, this one over here is this one over here, if you see, this is un plus 1 because we are building up, right? So we don't need to make un the subject. We are not going down, we are going up. So if this is u1, this over here will be u2 lah, correct? Right? Then this one over here we need to sub in 1. Okay, this one, if this one is u2, we sub in n equals to 2. This one what we get will be u3. Okay, so something like that. So we can just build up. Then the make un the subject, that one, right, will work on the next question. Yeah, your foresight very good. Can? Okay. So next one, it is known that the nth term of this particular sequence comes up to this general formula. Okay, find A, B, and C. So this one over here, very easy. Also another very easy thing. We got U1, U2, U3, right? So we make use of U1, U2, U3. Lor. So U1 will be equals to A times 2 power 1 plus B times 1 plus C. This one is going to be equals to U1 is 5. So 2A plus B plus C equals to 5. Equation 1. I think you can see where this is going already. Okay. U2 will be equals to A times 2 power 2 plus B times 2 plus C. This one is 15. Then I have a 4A plus 2B plus C equals to 15. This is equation 2. U number 3, this is equals to A times 2 cube plus B times 3 plus C. So you just apply the formula only. So U3 is 40. So 8A plus 3B plus C equals to 40. So this is equation 3. This is a simultaneous linear equation, 3 variable. So using GC, our A will be equal to 7.5 or 15 over 2. B equals to -5. C equals to -5. Very easy. Okay. So far, any questions? Huh? So actually, right, the recurrence relation question, right, not so bad one. Okay, better than the summation. Yeah, at least don't need to change variable. Okay, so part 3. Because of this, we want to find the sum from 1 to n of UR. Okay, in terms of n, right? So what we need to do, we need to make use of the general formula over here. Okay, so this one over here, I have a sum from 1 to n of k. A times 2 power n plus b times n plus c. Okay, Okay, so technically speaking now, right, we need to change a little bit. So now this is un, this is given as un, right? This is ur, so I need to change my expression. Okay, so instead of n, I need to change to variable r. So this one, be careful. Okay, because now is ur, u of r. Okay, previously it's u of n, now it's u sub r. Okay, so let's take a look at this. So how do we evaluate this sum? We split this up. So first one over here, 15 over 2, bring this out. Oh, sorry, 5 times r. Thank you. 谢谢. Okay, so like that. Okay, so this one over here, 2 power r minus 5 sum r minus sum of 5, like that. Okay, can or let's say, okay, can, like that. So first one, 15 over 2. What is the first sequence? Okay, maybe I won't write out yet, but what's the first sequence over here? This one over here is, what's the sequence like? 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, correct? And so on and so forth, right? So this one over here is GP with common ratio 2, correct? How many terms? N of them, right? Quite clear? This one over here, okay, this one, right, because we are summing 1 plus 2 plus 3 plus 4 until n, correct? Okay, sorry, this one instead of comma, I should put plus also. Plus, plus, plus. Okay, can? So this one over here, add until n, right? So this is an AP with common difference 1. Number of terms is n. So you can make use of Sn, n over 2a plus l, or you can make use of the identity half n plus 1, because we are literally summing from 1 to n. Okay? Can Last one. This one, right, we are adding 5 n times, right? Something like that. Can So let's make use of all these things and put everything down now. So now this one is 15 over 2 GP. So the first term is 2. Then this will be 2 to the power of n minus 1 divided by 2 minus 1. So this is the GP formula. Okay, minus 5 times of. This one I will make use of the identity if you are familiar with it. So this is half n plus 1. Last one over here, minus 5 times n. Okay, add this n times, so minus like that. Okay, so altogether, this one would be, okay, these and these can cancel. So I have 15 times 2 to the power of n minus 1 minus 5 over 2n plus 1 minus 5n. So I think you can further simplify to something like 15 times 2 power n minus 15 minus 5 over 2n square minus 15 over 2n. Something like that. Okay, so technically we are summing 3 different things at one go. Sum of GP, sum of AP or identity, then this one sum of the constants. Okay, all 3 at one shot. Can Okay, so only the last part is the jialat one. So this one 4 marks. Yeah. So this one is the jialat one. But I think otherwise should be okay. Okay, questions? Can? All good? Can? Can, all right. So with this, let's move on to our last question for this topic. Okay, question 12. Okay, before this, any question? All good? Hmm. Like here, this one. Yes and no, I would simplify this to 2 and 2. So I will simplify this 2 and 2. I will also simplify 5.5. So at least, right, I will stop here. Yeah, at least will be here to make the answer nicer. Yeah. Even though they say you do need not simplify, but yeah, I think this will be okay. Questions? Any questions? All good. Do you need me to go out and can okay. Not so bad, huh? Okay. All right. Last one. Question 12. Okay, very recent question. Got typo. Typo here. This one over here. This is not UN. This is U1. Typo. Yeah, because I think when you do halfway, right, then you realize that you cannot do. Okay? Yeah, this is a typo. Okay, so let's analyze and see how this works. Okay, so part A. A sequence is such that U1, the first term is P. P is a constant, and U of n plus 1, 2 times UN minus 5. So this over here is our recurrence relation. Okay, n must be more than 0. So the first term must be U1. Okay, now part 1, describe. So over here, right, you see that in A level, we have a little bit more qualitative stuff also. Okay, describe how the sequence behaves when P equals to 7, P equals to 5. Okay, so what are we going to do, right, is that okay, there is a way to do it using GC lah. Okay, but if you are a bit lazy, right, you can visualize what's going on. So when P equals to 7, what happens? What's the first term? When P equals to 7, when U1 equals to 7, right? What's the second term? 2 times 7 minus 5. 2 times 7 minus 5 is 14 minus 5, 9. Then 2 times 9 minus 5? 13. Then 2 times 13 minus 5? Then 2 times 21 minus 5? Yeah. Then 2 times 37 minus 5. Okay, you done one lay. Okay. 69. 74. Oh, yeah, correct. 69. You made me doubt for a moment, but okay, can. Yeah. So is this a GP or not? Not a GP, right? Correct. So how does the sequence behave? It's not okay. Technically, it's not irrational. It follows a certain formula. It follows. It's not irrational. It follows. Yeah. Correct. So the sequence diverges. Yes. Okay. So the sequence. Okay. If you want to be a bit more complete, is increasing and diverges. Okay. So part A. Right. Let's look at part B when P equals to 5. When P equals to 5, right? 2 times 5 minus 5. First term is 5. Second term is 5. Third term, 5. Fourth term, 5. Fifth term, 5. Agree? 2 times 5 minus 5 is 5, right? Correct? It's constant, constant. Yeah, the sequence is just constant or it doesn't change. The sequence doesn't change. Yeah. So Okay, something like that. Can all right. Part 2. So find the value of P for which U5 is 101. Correct. Now, so for this one over here, I'm going to take Izen's recommendation from earlier. Now, right, because we are defined, the relationship is defined as this is U5, right? I need to find U4, correct? So technically speaking, I will need to make this the subject either way or another, correct? So why not make the process easier by just making this the subject first. Then I can just pump in one shot and see what's the sequence like. Okay. So over here, you have two ways to do lah. You can sub in and massage, or the other way to do is I will just make UN the subject. So this would be okay, U of n plus 1 equals to 2 times U of n minus 5. Then U of n would be equals to half times U of n plus 1 plus 5, like that. Can Okay, so this means that U4 would be half U5 plus 5. Right? So this is half 101 plus 5. So this would be 53. Like that. Okay. Now then U3 would be half times U4 plus 5. So half times 53 plus 5, which is 58. 58 divided by 2, 29. Okay. So likewise, you can do the same thing all the way down. Well, okay. So U3 plus 5. So half times 29 plus 5. This would be 17. Last one, U1 or P. This is half times U2 plus 5. 11, no, correct. So half 17 plus 5. This will give you 11. Okay. Now the other way is to substitute into this. Okay, the other way is to do 53 is equals to 2U4 minus 5. Then you make U4 the subject, U4 equals to what is so gay? Okay, 53. Okay, something like that. Then you put 53 equals to 2U3 minus 5. Then you make U3 the subject, 29, which same lah, same. Okay, same. Okay, and so forth. Okay, you can do both of these. Can Okay, so part B. Sorry, let me copy this. Copy. Okay. Anyone still? Okay, can All right, let's move on to. Is it okay? Are you feeling okay? Can Okay, don't worry so hard. Don't worry lah. This one is okay. Yeah. This one takes time. Okay. All right. Part B. Part B now they try to bring us another level. So this is a recurrence relation, but second order. Okay, that means we need two previous terms to get the next term. Okay. So another sequence is defined like that. Okay, and this one is the main rule. Okay. So this over here is the relationship. This over here is our initial condition. Okay, so it's like differential equation, right? You have initial condition to get your particular solution. So likewise like that lah. Okay, so this is the rule or the expression. Okay, now then they give another thing. For this sequence, we have this relationship over here, which we can use. Okay, which will be handy over here. Okay, so find the value of B. Okay, so let's take a look at what is going on over here. No choice but to start to work on it lah. We have no other leads, right? So what is, okay, so given, okay, given two, sorry, given, right, okay, or more like given this relationship, right, we have V3 will be equals to V1 plus 2V2 minus 7, right, correct? Right? If you, okay, this one is when n equals to 1 lah. Okay, when n equals to 1, you put the 1 inside here, put the 1 inside here, put the 1 inside here, right? You get something like this, right? Correct? Then you make it A and B, correct? So you can make it A and B. Oh, okay, sorry, don't write first. Don't write first. Don't write first. I show you first. Okay, don't write first. Something like that. So this is V3, okay. Now let's find what is V4. Okay, V4 would be equals to V4, right, will be equals to so this one is when n equals to 2, right? Correct? You get V4, right? So this will be V2 plus 2V3 minus 7. Don't write first, don't write first, because you know what's coming. I'm going to erase everything. So what is V2? V2 is B plus 2 of this minus 7. So this one over here would be how? 2A plus 3B minus 21, correct? Agree, right? Like that, right? Right? And what else do they do? Given V4 equals to 2 times of V3, right? So I will have 2A plus 3B minus 21 equals to 2 times this. Okay, can. Actually, can write. Yeah, because I tried this and I was stuck. So, okay, something like that. Okay, so over here, I will have you make, yeah, so B will be equals to negative 7 or 7. Yeah, B will equals to negative, no, B should be equal to 7. Yeah, why my B is not 7? 2A plus 5B, sorry, 5B. Okay, sorry, this one is 5B. Sorry. Then V4, 5B. Then this will be positive 7, correct? 5B, 5B. Okay? Can. So this is method 1. Okay. Okay, sorry, because I tried this and I was stuck, but yeah. Okay, but can. If your math is correct, then should be okay. Positive 7. Okay. Now, or the second way is, now given this relationship over here, so given V4 equals to 2 times V3. Okay. So at the same time also V4, right, you build the relationship. So this is V2 plus 2 times V3 minus 7, correct? Now then you observe that actually, that this one, this and this, correct? Right? You can do this, right? So V4 is equals to V2 plus V4 minus 7. And V2, right, is actually, this is B. Okay? And because of this, you can cancel this. And then B equals to 7 also can. Okay? So you have 2 different ways to do it. Okay? Can? Method 2 need you to see it. Then you can use. I would lie on method 1. As in my capacity, right, is method 1. Yeah. Have to see that it works. No choice. I also don't know how to explain. And this kind of thing, right, I also don't know how to explain. Like, whether can you see this thing or not? Yeah. I didn't see it. I did this and I died. So I've got answer long. Yeah. After thinking for a very long time, then we feel like, oh. Okay. Like if you ask me how do I think about this, right? A bit hard also. I can't give you a guaranteed one because sometimes coefficient will not match, correct? Sometimes the coefficient will not match. It's just very lucky that this one is just V4. Then you can cancel. Okay, huh? Can also? Can also? Technically can. Yeah. Okay, so this is part one. Part two, find an expression in terms of A for V5. Okay, so what is V5? Okay, so the thing about this one is now if you have already done this, right? If you already done this, right, you already saved the expression for part two. Otherwise, you need to do one by one to get V5. Okay, so over here, right, for part two, okay, what is V5? You need V3 and V4. So this will be A plus 14 minus 7, right? So this will be A plus 7. V4 is 2A plus 35 minus 21. So this would be 2A plus 14 like that. Can So technically your V5 would be equals to V3 plus 2V4 minus 7. So this would be A plus 7 plus 2, 2A plus 14 minus 7. So altogether you should have 5A plus 28 lah. Okay, something like that. So if you do this instead, right, then you will suffer a bit for the second part because you need to find what is your V3, V4. Okay, from scratch. Okay, in terms of A. Okay, now the other way, right? Okay, the other way to do this, right, would be, okay, the other way to do this would be, this one also require you to see it, but okay, so V3 plus 2V4 minus 7, correct? So V3, right, plus 2, what is V4? V4 over here is 2V3, okay, minus 7. So this one will be 5V3 minus 7, and then you can continue to get until 5A plus 28. Okay, so the idea is like that lah. You can do that also. Can so the thing about recurrence relation is, first one you can do by hand, which is to expand out the A and B and so on, and to sub and sub and sub and sub and sub. So this is the hard working method. Okay, which there are two kinds of people lah. People who work hard and people who work smart, right? So this is the people who work hard. Then the one on the right is people who work smart. But the thing is, I'm a hardworking person lah. I lie in the camp where I'm on the left hand side one. But let's say if you can see it, then if you want to be a bit more lazy, then you try to find the relationship. So the nice part about this question is that because they already explicitly link V4 and V3 together, you can simplify this recurrence relation, right, with something simpler like this. Okay, so that's the beauty about recurrence relation is that you can always use the previous term over here if they give a relationship. Okay, can okay, what's the next lesson? GP. I will save the last part for next lesson. Okay, I'll save the last part for next lesson. And next lesson, I will start to do a bit of revision for the previous topics to start WA revision. Can? So, if possible, bring your topical revision next. Sorry, bring last year's topical revision. Yeah, bring last year's topical revision for the upcoming lesson, the 2024 JC1. I will do for chapter 14 and 15. Okay? Can all right. So with that, I will can. So let's stop. Can? Correct.